The topic of this video will be the addition of hydrogen halides to alkenes. This is an electrophilic addition to alkenes, so the general reaction will look similar to the general reaction of the electrophilic addition to alkenes. Our alkene will act as our nucleophile. The other molecule will be a molecule of HX, a hydrogen halide. The proton is the electrophilic portion of this molecule. The halide is the nucleophilic portion of this molecule. And the molecule of HX will add across the double bond to give us an alkyl halide product. Again, the mechanism will also look similar to the electrophilic addition to alkenes. First, the nucleophile will attack the electrophilic portion of the HX molecule. This will cause the loss of the nucleophilic portion of this molecule, producing a carbocation and a molecule of the nucleophile, a halide in this case. In the second step, the nucleophile that was just formed will attack the carbocation, producing the product. Now let's look at a specific example of an addition of a hydrogen halide to an alkene. The addition of HBr to this alkene produces one product. We see addition of bromine to the more substituted carbon of the double bond. To understand why we get this product and not the other possible product, we need to look at the mechanism for this process. In the first step of this mechanism, the alkene nucleophile attacks the electrophilic portion of the HBr, which is the proton, kicking off the bromine. This produces a carbocation. Two possible carbocations can form. The proton could add to the more substituted carbon of the alkene, producing the less substituted carbocation. Or the proton could add to the less substituted carbon of the carbon-carbon double bond, producing the tertiary carbocation. As we've seen previously, a more substituted carbocation is a more stable carbocation, and therefore forms more quickly. Therefore, we get the product in this reaction that results from the tertiary carbocation only. In the next step of the mechanism, the bromide that was formed in the previous step attacks the tertiary carbocation to form the product. This is the major product resulting from the more stable carbocation, and it's said that this reaction follows Markovnikov's rule. This rule states that the addition of a proton to a double bond of an alkene results in a product with the proton bonded to the carbon that has the greatest number of protons to begin with. In other words, we say that the product of the above reaction is the Markovnikov product because it follows Markovnikov's rule. We can restate Markovnikov's rule in more general terms that can be used for any electrophilic addition, which is that the electrophile adds to the alkene in such a way to generate the most stable intermediate. We will see that many electrophilic additions to alkenes follow this rule.